Hello, my fine friends. Am I on? I believe I'm on. Yes, I'm doing that. I'm doing that classic video conf meeting thing of, hello, can anyone hear me? I don't know. No, you're going to hear me in an hour. There is a time slip going on right now. I am displaced. Temporally displaced. And it doesn't feel good. I could have done with that extra hour today. But here we are. This is the price we pay for having plenty of time in the afternoons to spend more time at work during daylight hours instead of spending time at work during night hours. Maybe this year I should resolve to be spending after hours time out of work instead of just more time in work. That would be quite a change. Okay, so first, I acknowledge the traditional owners of this land, the Whadjuk Noongar peoples. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. Now, no music. You are on audio and video this time. Thanks, Stephen. Okay, so before I get into saying hello, yes, I am coughing. My lung infection thingy, whatever it is still there, like 2.5 weeks later. So I am still not sleeping properly because I can't, because I just spend all night coughing. But I will, I should be fine. I should be fine. It's just that I will probably end up having to hit mute on myself a few times. So, where are we? Okay, I am looking at chat. The TTS is not working again this week, so I have to do this once again the old-fashioned way. So, good morning to Simon, to Stephen George, to Sharky, Scott Miller, Crispian, aka Outside the Box, John Whips, and scrolling down, Russell Rainey, Immy is here as well. Also Grant Mazels, good morning. Andrew Ruthven, Andrew said, switches from watching last weekend's stream to this one. Yeah, Crispian says, so you had it first. That makes it my fault. It does. Yep. Scott says, got a schizophrenic bash script into a functional state just in time to put it aside for the stream. To put it aside. Okay. To have it committed, is that what you did? When you say put it aside, is that a euphemism for having your script committed to a ye olde mental asylum? Maybe. We have text to null this week. Use the command /null before you say anything to send it to null. Yeah. Text to nothing. Nothing. Goes nowhere. I saw the comment from Crispian saying feeling crook still. So I'm sorry to hear that. I hope you recover quickly and that does not drag on. Okay, so today I have an idea. I have a plan for what I want to talk about. And it is a follow-on from last week. But before I get into that, here is the cue for all of you to start dropping. Oh, and Lionel is here as well. Cool. Hello, Lionel. Here is the cue for all of you to start dropping nerd brags into the chat. What cool thing have you done? What are you proud of? What have you achieved? It could be a little thing. It could be, I managed to do a load of washing this week. Actually, along those lines, last Sunday after the stream, so this is legitimately something that happened in the week gone since the last stream, I cleaned the bathroom. I got like spray and scrubbed everything and cleaned everything and yeah, made it all sparkly and shiny. So that is my brag. I actually did something. I did something useful for a change. Simon said, I successfully procrastinated. Nice. Yes. Okay. Now, what I'm going to show you, Scott says you learned the tiles are actually white. No, I think they are kind of like a yellowish color, like an 80s era, fairly disgusting sort of style. Andrew said, opened 2 pull requests against Arclone for quality of life improvements. Nice. Okay. That is a nice nerd brag. Arclone. What is Arclone? Is this something I've never heard of, or I have heard of and forgotten? So it is a command line program to manage files on cloud storage. It is a feature-rich alternative to cloud vendors' web storage interfaces. Okay. Described as rsync for cloud storage. Command line program to sync files and directories to and from different cloud storage providers. That's cool. Okay, so if you've got like stuff in, I don't know, Amazon S3 buckets and something in Google Drive and something in whatever, maybe, I don't know what services it supports, but it allows you to synchronize between them or manage files between them. That could be a very useful thing, because one of the conversations that I've had during the week, well actually we've had multiple conversations on this topic, is NASs. NASI, what's the plural of NAS? If you have multiple NAS, is the plural of NAS data center? I don't know. Andrew says, yep, all of those, many, many more. Oh, right, okay, cool. Okay, so a nerd brag from John Whips, who said, repaired the fence that blew down in a storm. Nice. Good work. It's good doing something physical, doing actual practical things. I spent the day yesterday doing physical practical things. I helped my son with moving a whole lot of furniture. We went to Bunnings, we hired a ute, we drove down to Blackrock. Actually, we went to other places first, but we went to Blackrock, picked up a bunch of furniture, made a run to the tip, went back to Blackrock, picked up more furniture, made a run to Croydon. Yeah, so it was a day of driving around with a ute, moving stuff, doing practical things. It's good doing practical days sometimes, not just sitting here going shika, shika, shika on the keyboard. Scott says, plural of NAS is expensive, overpriced gear. Yep. Scott says my bash script is cloud related too. Ooh. Okay, another nerd brag. Lionel says, I met my job application requirements for the month. Well, that's good. That is a good achievement. And that can be hard to do. What else? And again, new price on my storage machine was in 5 figures. What? Okay. That's an expensive... That's an expensive machine. Okay, so keep the nerd brags coming in, because it is really cool hearing what people have achieved. And taking a moment to feel good about yourself and that you have done useful things. Just hold on to something. Doesn't have to be a big thing. Just the smallest thing is all it takes, and hold on to it. Hold on to something positive. Right. Now, something... No. I was about to go down a squirrel hole. Squirrel hole? Squirrels don't have holes except where they hide their nuts. So, then again, Scott says, but I got paid to remove it. What was this in reference to? Oh, Scott says, but I got paid to remove it at end of lease. So this is, you got paid to remove a piece of storage equipment that was in the 5-figure value range, and now it's yours. Now that is a good deal. Here, have some gear and I will give you money to take it away. That's, it doesn't get any better than that. That sounds pretty damn good. Oh, okay. Now, last week we were looking at... okay, I'm going to do a little bit of screen rearranging here. Yeah, last week... Oh, and I'm going to bring... Amanda said, squirrels go up a tree. So I've heard. I like climbing trees. IT support is a good scam. Job. Yeah. Okay. So let's leave that fairly big. We'll leave this fairly big. And these are notes. So softwarestructure.md. These are notes from previous discussions that we've been having about how this should be done. Did I do this on stream? I think I did. I can't remember. I think this document was one that I wrote while we were talking about this on a stream. Maybe. Maybe. Hang on. I need to pause to take a swig of this beverage. And to cough. So, yeah, that's like hitting a quad power up in back in the olden days of multiplayer gaming. Quad power, what was it? Quad damage. I just vaguely recall there being like this blue sphere that you would run through. What did it look like? The quad damage power up. I can't remember. Anyway, some of you will know what I'm talking about. Some of you will have no idea. And it doesn't matter either way. Back in the days of super fast. Well, that hasn't changed. Okay, I am really not on topic today. I've got as far as opening this document. Now, Testomatic, which, let's start it up. So I've got the Testomatic right here. It's not even turned on right now. This test module is just sitting on top of it. This is kind of in the state that I showed you last week. So I'm gonna just turn it on. The fan spins full speed for a moment and then turns itself off. And it's booting. So in a minute we will log into this. Will I plug this in? Yeah, that might be useful at some point during the stream, so I'll plug that in, the breakout for all the I/O pins. And then we will jump on a shell on that box once the Pi has finished booting, which should not take very long because I will show you what I have managed to do. I'm just gonna Testomatic tester, that one. Just looking at my history. Okay. Okie dokie. This is, the boot's pretty fast actually. It's a Pi 4? I can't remember. Anyway, it only takes a few seconds to boot, which is nice. Oh, Grant says, my NAS is an HP microserver with Xigmanus, FreeBSD with ZFS and a web interface. I have not heard of that one. Xigmanus. ZFS does good stuff. So, Xigmanus. Oh, okay. I just read it as a single word and I said Xigmanus, but it's Sigma NAS. Right, I see. So, my friend Matt and I have been having this conversation about NASs, and the end result is that he's about to build a true NAS Yeah, a true NAS, as an experiment, because he was tossing up all of these options like Unraid, TrueNAS, Open Media Vault, all the classics. And it got to the point where we were going around and around in circles discussing all of the pros and cons. And he said, stuff it, just going to do a TrueNAS install and play, knowing that that he might end up blowing it away and switching to Unraid or something else. But you got to start somewhere. So yeah, the two of us ended up in decision paralysis. And the way to break the paralysis is just to pick one and do it, and then see what happens. And maybe you'll regret the decision, maybe you won't. But at least you're doing something, and then you can adjust course. Once the ship is moving, then you can adjust course. But you got to get moving first. Crispian said, hot weather today, 24 in Ballarat. Yeah, 24 here too. It was 24 here yesterday in Melbourne, which was nice. We were moving things like carrying a bed and various other bits of furniture, carrying it from an upstairs apartment down some stairs and then loading it on the ute and that sort of thing. So we were physically moving heavy stuff around yesterday at 24 degrees in full sunshine, which was pretty much perfect. I like cool weather. That's what it comes down to. I do not like overheating, but that sort of temperature was just fine. Any more than that, and it would have been getting into sweaty territory. Scott says, tiny little Celeron machines make expensive power bills. Yeah. That's the thing is I have so much old hardware. I have several racks worth of rack mount enclosures sitting up on the mezzanine, probably, and they're not light. What have I got up there? I've probably got something in the region of 400 kilos, 500 kilos of rack mount cases. Just sitting, maybe not that much, but it's a lot. Rack mount cases are heavy, and when you load up a full rack with gear, with hard disks in it, a single rack can weigh an enormous amount. The floor loading in data centers is shockingly high because they're basically, racks are basically big lumps of metal full of other lumps of metal. And the per square meter weight that you're sitting on the data center floor is very high. So anyway, I've got all of that. I've got all the old computers from IVT. They'd be 7, 8, 9, 10-year-old, that sort of era machine now. And running up a 10-year-old machine these days is not very efficient. So it's in a situation where I've got all of these computers that I could use to set up a NAS, but they are probably not the best candidate. It's possible that it'd be better to get something new. Grant says the HP microserver N54L does not use a lot of power. Yeah. Grant says Sigma NAS is a fork of TrueNAS. Was called FreeNAS for a while. Oh, okay. Yeah, FreeNAS. Okay. I knew of FreeNAS. That explains Sigma NAS. Okay, Grant. Here is your mission. You said that you're happy with Sigma NAS, aka FreeNAS. I remember a while ago that there was a whole lot of drama. Like the whole reason that there is TrueNAS and FreeNAS, I think, was that there was a fork, like a split in the project, some big political falling out, arguments, people like screaming at each other and saying, I'm going to take my bat and ball and go and play by myself. Something like that happened. I don't remember. It was years ago now. So I think TrueNAS and FreeNAS, one was a fork from the other, whichever way around it was. So, are you happy with Sigma NAS? Is my very brief question. I could ask a much bigger, more complicated question, like what NAS software do you recommend and why? But that would require an essay level answer, so I'm not going to do that to you. Okay, now, what am I doing? I've been on this shell on Testomatic. Let's see if I can zoom in more to make this text really big. And I'm going to show you some embarrassing stuff. What have I got here? Okay, so look up here. You can see these folders, 805593R. These are experiments with drivers. And yes, I know I should have been getting this instead of copying directories. That's because I am not a proper. I'm not a proper engineer. I don't engineer good at all. Okay, so I will just show you briefly what I did after the last live stream, where I've got to with these drivers. So what's the mod date on this? Yeah, you can see the modification date's 29 September, 30th September. So it was, what day? Monday? Tuesday? Something like that. Anyway, so, oh, Andrew said, it seems that in 2020 FreeNAS merged with TrueNAS. What? Oh, okay. That's not the news I expected to hear, Andrew. So what I've got here is some. Let's just have a look at one. Your analog read. Is this? Yeah. What's going on with this? Yes. Okay. So this uses a library. Actually, no. I'll start with the library. That's a better way of doing this. Vim 805593R library. Whoops. And then we're going to open another. So this started off by as a library for MicroPython by Tristan Muller. Comes from 101 Robotics. And it was the closest thing that I could find that would talk to the AD5593R, but it didn't actually do all the functions. It was missing a few things. It would do some basic I/O, but it was missing a whole lot of stuff. So I did some modifications to it, and it now has DAC mode as well, so we can write to the DAC, and there are all the control registers. Most of this stuff you don't really care about. This is just underlying foundational things. So we give it, you can tell it the I2C address, or it just takes a default. You pass it the I2C bus as like object. You have to invoke that first and then give it to it. Then you can check if the device is there. You can do input, output, ADC, and DAC operations. So this is all new stuff that wasn't in the original library. Digital read. So get vref, and it's got these other functions as well. So get vref, which is what the reference voltage setting is in the thing. You can set the vref. So typically vref on an ADC can be set to one of several different things. You can supply you can tell it to use its own internal reference voltage, which is just the quick and easy way of doing it, and that's what I normally do. Or if you want super precision, you can supply an external reference voltage, and then you can, using a precision voltage source, and then you can tell the ADC to use that external reference. And there are different multipliers and things. So typically what you would do is, if you have a 0 to 5 volt range that you want to read, then you would give it a vref of 2.5 volts, and it would be a precision 2.5 volts. And the readings are taken relative to that 2.5 volts, and then there's a multiplier that's added. So there would be a 2 times multiplier, which means that you then get the full 0 to 5 volt range. So anyway, you can set the VREF multiplier. Blah, blah, blah. You can read a voltage, and this takes, all this does is take an analog reading. So it's a 12-bit ADC, so it'll return a value between 0 and 4000, whoops, 4095. Why does that say 4096? Divided by 4000, oh, okay, yeah, it's just the division. Oh, what? I keep hitting the wrong thing. So 4095, it's a range. So this is, yeah, you can see here, for example, in the analog write, it's a 12-bit, DAC. So it's clamping between 0 and 4095. And when we do the, where are we? Further up here, where we do the, here we go, read voltage. Yeah, we get the value from the ADC, we divide it by 4096 and then multiply it by the VREF, which tells us the actual voltage that is being read on the pin. Now there is some more work to do on this, because what I'm finding is that in my initial tests, the values that I'm getting back are not quite scaled properly, and I haven't yet figured out why, but I will get to that. Anyway, I am skimming through this super quickly because this is not really the important thing right now. This is just giving you some background on what's happened. So we've got analog read, analog write, which uses the DAC to produce a continuous voltage, like a proper analog voltage, not a square wave PWM voltage equivalent, but an actual DAC, digital to analog converter. So we've got reset function, validate pin. This is checking whether it's within the range. So it's helper functions, I2C helper functions. So this is reading a register, writing a register. So register ID, most significant byte, least significant byte. Read values, read, write. Yeah, so that's just I2C helper stuff at the bottom. So none of this, the details in this are not super important. And the idea is that you should be able to use different I/O modules. Oops, no, I do not want to modify it. You should be able to use different I/O mods with different chips on them and not care about the underlying driver. The driver itself, you obviously need a driver for whatever chip you're using for I/O, but let's take that as a given that we have a driver for whatever the thing is. Okay, so then with that driver, I/O mod example, yeah, let's have a look at I/O mod example. I think this is where I've been through several iterations of this and I can't remember. Yeah, so no, this might be going a little bit too, I'm trying to do this in sequence, and I think this is jumping ahead because it's got the TCA multiplexer involved in it as well. So this is doing a whole lot of, this is basically exercising a whole lot of functions of the module. And so let's ignore that one for now. That one's too complicated. It is much more than I want to be showing at the moment. Yeah, the test I/O mod. Let's have a look at that one. No, I'm going to look at 805593R analog read. Analog read, that'll do. Okay, so if we come back to here, what we do is import the library. Now, the whole point of what I'm getting to here is I'm starting from the lowest level, which are the details that you should not have to care about, and moving slowly up the software stack. So the library we just had a look at. So wipe that from your memory. We don't need to know about it anymore. What we are doing is, from that library, we're importing 805593R, and we are initializing I2C, etc. So we are doing all of the necessary stuff. Scanning devices and reading from, what have we got? Main. Okay, so we're creating the I2C object and initializing. So this is using the library that we just had a look at, and then there are functions like set vref true, which is that thing that we were just looking at in the library. So we've got the object that represents the IO mod, and we're setting the reference voltage, and in this case what we're doing is setting pin number 2 as being, well, it says pin 3 but it's 2, as being an analog input. So we're saying the IO mod dot ADC pin number, and then reading analog voltage. There's a loop here, so 20 times it reads and then displays the result with 200 milliseconds in between, and then exits. So that is an example of using the library that we just looked at to create the I2C connection, like initialize the connection to the IO mod and do an analog read 20 times and spit the results out. So that is, where are we? I'm going to come back down to here. So the reason that these, I glossed over this a moment ago, the reason that these numbers are different is that I was actually stepping through and trying different numbers and things. I was trying different pins on the chip. Now, one thing that you will not see here is a way of selecting the module. And if you'll remember, we have multiple modules and we need to use the I2C multiplexer to connect to the correct module. None of that is in this script. So this is an example of assuming that you have an 805593R which is on an I2C bus and you are connected to that bus. It assumes that homework has already been done for it. And that is taken care of by select module. I'm going to vim it so that we get the pleasantness of syntax highlighting. So what this is doing is using Adafruit's driver for the TCA9548A, which is the I2C multiplexer, and it is once again initializing I2C, creates the object that represents the multiplexer, and then in this case I've selected channel 3, which is the 4th IO module. So it's A, B, C, D, it's IO module D, and we're getting a lock on it, and that's it. So you can see the stuff, whoops, you can see the stuff commented out there, but in the simplified version, all it does is pick the 3rd channel. So the way this actually works, let's try this. I'm going to do, was it module D, A, B, C, D. Okay, so D is connected to, yep, it's got its reference voltage, D 0, 1, 2, 3. I think it was pin 3 that it was reading. I'm going to, actually what I'm going to do is change the reference voltage to 5 volts. Sorry, I was off screen there. What I'm doing here, this is my dodgy test setup. So the outputs from modules A, B, C, D. So this is the 4th one here, which is channel 3, because it's 0, 1, 2, 3. I've got the reference voltage connected to 5 volts. I've got the, which reminds me, I should turn on there, 5 volt power rail. Then I'll turn on the 3 volt power rail as well. Then this is input 3. So it's D3. I'm going to plug this into, Oh, in fact, I'm going to unplug that and I'll use this cable. I'm going to plug this into, oh no, that jump off feels it's so dodgy. I'll use this one. Into 3.3 volts. Oh, come on. So what I'm trying to do here is just demonstrate reading from an analog input and seeing the value that comes back. All right, so we've got a 5 volt reference now, and we're feeding 3.3 volts onto it. And the whole point of that is that we should see a value that is not 0 and it's not full scale. It should be somewhere in the middle. So somewhere around 2/3 of the value. So now what I do is I go select module, ba-ching, channel lock acquired on 3. I should have outputted a new line after that. Okay, and then I'm going to do AD55 analog read, and that is not right. Demo fail. So why not? Setting pin 2. Oh, pin 2. I've got it plugged. I've got the jumper plugged into the wrong pin. I had pin 2 selected. Okay, I'm going to move that across to pin 2 and up and go, and let's see what happens now. Oh, that's better. Look at this. So now we are getting a reading of 2.372 volts on that pin. So we're getting a value of 3887 out of 4095, 94.5. Yeah, so I need to figure out what's going on here. That value is wrong. That should be about 3.3 volts. And it doesn't make sense, the math doesn't even make sense. So I've got to figure out what is happening with that. But at least now, as you can see, in fact, what I'm going to do is I'm going to run that again, and while it's running, I'm going to pull that jumper wire out, and we should see the value drop. So pull it out now, and now you can see the value drop. So it is not properly calibrated, but it is actually interacting with the AD5593R now. Okay, but if you had to do analog read, but if you had to do all of this every time you wanted to read from an analog input, that would be painful. So we need some helpers. And if we look at, let's see, test. So this is, I think, where I'm getting to. So this example is, so the whole point of this is that what I'm trying to do is push the complexity down the stack so that at the top level, when you are defining tests and saying, I want to drive this pin high and I want to read from this pin, that should be as easy as possible. It should be really, really simple. And so this is where I am at the moment. And so what I've done is created some helper methods in the library. So we've got scan for available modules. It shows us what modules we've got available. Oh yeah, so iomod.scan modules. That is a helper function inside the iomod library now. So in that object. And you can see that there is an iomod.init, which assumes default values. So it's, and also the iomod library wraps the TCA multiplexer library, and it takes care of it. Oh, sorry, no, the iomod library. I've missed a level here. Okay, we've been looking at the AD5593R library. So this is the other thing I did. iomod library. So this library includes and also it barely requires saying that I don't really have any idea what I'm doing here, so the way I'm doing this is probably really messed up and not very nice, but anyway. So what this does is it's a wrapper for the AD5593 and the TCA 9548A, and it deals with both of them. So in this case, instead of having to call the script to select which channel you want on the multiplexer and then talk to the device on that channel, this takes care of it for you. So it does the necessary stuff for talking to the multiplexer using the Adafruit library, and it uses the AD5593R library that we were just looking at a second ago. Got some constants, and that's annoying. I'm going to do that just because. So it then does all the necessary stuff. So it yeah, there's the scan method that we just saw a second ago, and we will return to in a moment. The write to method, the read from method. So here we got IOMod. This is the actual class. So what it does is sets up everything necessary with the I2C multiplexer right here. So it creates the multiplexer object, and I'm going to skip over a bunch of things. These are just constraints to make sure you don't try to call pins that are outside the allowable range. Then, what is this? Return module. Yeah, okay. Then wrap the multiplexer. You can see here that we've got the default I2C address. It then creates the object for the actual IO, like the AD5593. Now there is a whole lot of stuff here that still needs to be abstracted one more level away, and I don't think I'll talk about that today. But the thing is that right now this only supports the AD5593R. What if you're using an IO module that had an MCP 23017 on it, or a 23008, then this part here would all be broken. So there needs to be a way of specifying what module it is and then invoking the correct driver. At the moment this is all hard-coded for just that one type of module. And yes, I know that's a problem. That is a problem for future me to solve. Okay, so then we've got methods for digital write, digital read, etc. So the idea is that if you want to do a digital write, what you do is you say what module you want, what pin you want, and what value you want, like high or low or whatever. So then this all takes care of doing the actual stuff underlying. There's an analog read wrapper, there's the analog write wrapper, read voltage, and setting pin mode, so you can explicitly set pin modes, set the VREF, get the VREF, blah blah blah, toggle pins, scan modules, which looks at all of the possible, looks for devices on the bus and then tells you what it finds. Oh yeah, and then just at the bottom it's just convenience functions, which we don't really care about. And there's a usage example. Okay, so, oh, come on. Oh, that's right, that's because I changed the formatting at the start. Screw that. So then, okay, the end result of all of that mess and abstraction is that we can do something as simple as this. And even this is more complicated than it needs to be, because I'm using time in here for the sleep and it's doing a loop. So what we do is IOMod, so this is the wrapper library, initialize it, and that takes care of setting up the driver for the AD5593R, the driver for the I2C multiplexer. It initializes the I2C bus, and it is then ready to do what we want to do next. So then we say modules is scan modules. We don't actually even have to do this. We can we could comment this out. This is just an extra bit of noise, really. And then say we want to write hi to pin 4 on module 3. It says pin 4 there, but once again I kept changing this value because I was experimenting with different things. So in this case, what it's doing is driving its blink, basically. So it's driving this pin high and then low 20 times in 0.5 second increments. So we would end up with a blinking LED coming off this. And I'm going to turn on. I've got to turn on my workbench so I can get the scope. I know I'm rushing through here because none of this is actually what I was wanting to talk about today. I'm trying to get to the bit which I need to do next and where I'm going to need lots of input. So, sorry, I'm just pulling up Node Red so I can turn on my workbench. Bench 1, here we go. Click, clickety click, and everything should turn on. And including the oscilloscope, because I want to see pulses coming out of this. Come on. Oh, the workbench is being laggy. I'll hear some more clickety clicks in a minute. Okay, so I have not been reading chat at all. Wagon Load says, I designed an ADC that has no math, 1-to-1 decimal output, 0.001 equals 0001, and 9.999 equals 999. That's interesting. That's kind of cool. What else is there? Okay. John's ADC calc shows a drop of 0.5 volts. Yes. Every boot I'm editing at Grub haven't been able to. Wagon Lows asks, can the driver be linked to the I2C address it finds? Yes. So, are you suggesting that it's like an auto discovery for modules? Because that is an interesting idea. So if you activate an I2C channel and you then scan it and you find a device on it with an address of hex 10, you know that you've got an AD5593R on it. If you find a device with address hex 20, you know you've got an MCP 23008 or an 017. Is that the sort of thing that is that what you were getting at? That is actually a really interesting sort of approach. But there is a whole test definition and config thing that we will get to, which is actually the point of what I was wanting to talk about today. Yes, okay, cool. I did understand correctly. Yes, so doing that, I think, would be an extremely useful safety net, because what I want to talk about in a little bit is how do you define tests. Part of that is going to be specifying to run this test suite, we need an AD5593R in slot A, and we need another one in slot B, and we need an MCP23008 in slot C, and we need this high accuracy ADC chip in slot D. You know, there might be a combination of I/O like that you need to have for the electrical connections to make sense for your device under test. Now, what I have in mind is when you define your tests, you specify what each of those things needs to be. So there'll be a configuration for each of the modules or each of the I/O blocks. And then what you could do is when the test runner is beginning the test, it could query each of the modules and check whether the module that it's seeing on the bus matches what it has been told to look for in the test configuration. And if it doesn't match, it should not run the test. So it should come up with an error saying incorrect module in slot B or something like that. That is a really useful thing to do. Because, yeah, that'd catch errors of people who have not reconfigured the chassis properly when they're switching to a different, a different device, like a totally different test configuration. But yeah, doing that in the library, yeah, that is a very good way of thinking. So yes, I like that. I wouldn't rely on it as in the sense of just taking whatever module is there, because one way you could do this is, imagine all you cared about was simple digital reads and writes. You could do that with one of several different modules, and the test could say, I want to do a digital write on module A pin 1. And it doesn't actually care if it's an AD5593R or if it's an MCP23008. The test runner could just load the appropriate driver and do a digital write on that pin. And that would abstract the test definition from the chip that is on the module, and they would be functionally interchangeable. That is also a very interesting way of thinking about it. But I think that is a potentially dangerous way of thinking about it, because it could allow you to run tests that seem like they're working, but they're not, because the underlying system has auto-configured itself for the module that it discovers, and you are telling it to do something and you are getting a result, but the module may not actually be capable of the functions that you need to run that test. Like it may not, you might, for example, do an analog read of a pin, like because you're measuring a reference voltage, and you've got a module in there that has a 10-bit ADC on it, but your test requires a 16-bit ADC. You're getting a value back, but you don't actually know that it's measuring it accurately enough or precisely enough. Wagonlight says, read my second question. Okay, I will get to that. Yeah, but so there are nuances to this, but Wagon Loads, I absolutely agree that detecting modules is a very useful aspect of all of this. Okay, now where is Wagon Loads' second question? Do the IO mods have a Who Are You name? No, they do not. The way we could tell what they are is by seeing if they respond at a certain I2C address and then make assumptions. So it's not a foolproof method. What you could do is, if you had, say you had two ADCs. Okay, I'm just making up a scenario here. I don't even know if this would work. Imagine you had ADCs from two different manufacturers and they both appeared at the same I2C address. So you scan the bus, you see, I've got a device at hex 24 or whatever it is, and you don't know if it's from manufacturer A or manufacturer B. You could then have an extended identification process where you do things like query it for specific registers and see if the register matches what you expect from the thing from manufacturer A or the thing from manufacturer B. And then you can say, oh, I've got an ADC from manufacturer A at this address, or from manufacturer B, and then invoke the correct library to match. So that's the only way I could really think of doing it. Wagonlight says, what about sending out a command that a certain device responds to and see if it happened? Yeah, that sort of thing. So basically, you're experimenting against the device to see how it behaves, and from that you're inferring what type of device it is. Yep. Yeah, so that sort of device discovery could become quite sophisticated, and I think that's something that may need to be developed in future. At the moment, that doesn't exist, but it's a very worthwhile thing to think about. that could be really useful. Okay, so then what we've got is, you can see we've got IOMod digital write. Did my bench not turn on properly? Because I do not have, that's weird. My workbench half turned on and half the devices didn't. So let's see, I'm going to try turning it off again and then turn it back on, because I specifically want to get the oscilloscope up next attempt so that we can see the output from the pin, because just putting an LED on it, not that satisfying. Oh, come on. Why is... That's annoying. Scott says Conan unplugging things again. Yeah. Yeah, Scott says, have to be careful what commands you use for that. Yes, true. Yeah, it would take a bit of thought. But as a general principle, I think the idea is a good one of discovering devices on the bus by scanning for devices at addresses, which narrows it down, and then once you've got an address, it will be one of a certain number of things that could be at that address, and then use techniques to figure out which of those devices it is, like whether it responds to certain register addresses at all, how it responds, what values it has in different registers, that sort of thing. You could probably figure stuff out. Now, that is annoying. It's not a problem that I want to solve right now, but my those Z-Wave power boards that I use for running everything, whatever is going on here right now means that one of the power boards that is under my workbench is not turning all its outputs on. Hang on, I'm going to see if I can turn the scope on explicitly. Nope. No, the power board is not responding. I'm just using my phone to try to fire it using Node Red, sending commands to MQTT, which goes to Zigbee to MQTT. No, Z-Wave to MQTT. Sorry. Okay, so what's happening here is a fair bit of this you only do once. Some of you don't need to do it all. So this has got scan modules, and here you'll see it's got printf available modules, and then it lists the modules. And you'll see that it'll actually respond twice, because it's also responding inside the library, because some of this I copied out of the library. So yeah, there's cleanup to be done. This is at the point where it kind of works, but it needs TLC. So we've got a digital write, module 3. Now, I was trying to figure out whether I should have definitions for I/O blocks. In fact, I'm going to... Where is it? Oh yeah, I've got somewhere here I was playing around with formatting in JSON. I was talking to people in Discord about this during the week. Not there. Not there. I'm looking for a... not there. I'm looking for a browser tab. Oh, it might be in the same window as that. Nope, 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 nope. Okay, I had it around somewhere. Sorry, I was just trying to find something that I had open. I had an online JSON to YAML conversion thingy open, and I was playing around with it during the week, working out how to define tests. Because what I've been doing so far today is working from the bottom up of the driver to the chip, moving up levels of abstraction to the thing where you are calling pins on the chip. But at the other end, coming down from the top, we need to define the tests. And that is really what I want to talk about today, is that top level of how do we say what the tests actually are. And that is kind of a problem. So what we've got here is, but where the blinking cursor is, that is relevant to this whole thing. So that first argument is which channel on the I2C multiplexer we want to reference. So this is channel 3, which is the 4th device because it's 0 indexed. So this is going to be, so this could be, I'm just going to do this, it could be referenced as block D, for example, if D was defined somewhere as the identifier, or this could be block D and as an actual human readable label, and for reasons that I will show you later. But that is a whole, I'm getting ahead of myself there. How do we define what the IO blocks are? That is a meta question that I will get back to. Okay, so what we're doing here is block D, which is the 4th module, pin 1, we're driving it high and we're driving it low. So if we actually run this and I go test IO mod, blah, blah, blah. So you can see that it's found modules in slots 3 and 5. What this has done behind the scenes is that it has stepped through each of the I2C buses on the multiplexer, queried them and checked whether there is anything in existence on that bus. And you can see that it's found modules on 3 and 5, because if we come back to here and look at here, you can see that I've got a power connection going to 3, which is the 4th one, which is block D, and I've got a power connection here going to the 5th one. So the 3rd, so it goes 0, 1, 2, 3 is powered up, and 5 is powered up. Now if I'm going to get rid of that. Now if I connect, I'll move this along to block 4. So this is now powering up E. And if we come back to here, you can see here available modules are in slots 3 and 5. If I now run that again, you can see it's reporting 3, 4, 5. Now there is a phantom. 5 should not be visible, but that's because of that module was just powered up and it is still awake because its reference voltage was set. If we do that again, yeah, after a little while, number 5 will go away because its reference voltage will have bled off. That's a high impedance input on the thing. There is no bias resistor or whatever on it. So once it's been set to a level, it'll tend to stay there until the voltage bleeds away. So eventually that will stop reporting anything. But you can see that at the moment it thinks it's got IO mods in blocks 3, 4, and 5, which is D, E, and F. And that would have been blinking the LED. In fact, I'll see if, let's see, do we blink an LED? Hang on, why is the overhead? Oh, I pressed the wrong one, that one. That's what it should have been. Okay, so what pin was it? So it was module 3, pin 1, that one, pin 1, which is the pin there. So if I go, how am I going to do this? I think the answer is jumper wires. So I'm going to plug that into pin 1, and I've got an alligator clip here, so I'm going to put that onto there. This is all going to be super ugly. And then this onto the anode side of an LED. Then I want this onto the cathode of the LED. And then this, I need to go to ground somewhere. There's a ground up here, that'll do. No, I don't want it to go directly to ground. I want it to go to a resistor. What should I use? I've got a random random thing of resistors in here. Oh, there's a 220 ohm. Red, where is it? Red, brown. It's a 220 ohm. So I'm going to stick that there, and then I'm going to stick this resistor into ground. So in theory, this LED should blink at 2 Hertz. Let's go up, and is it going to do anything? Yeah, there we go. Okay, so we now have the LED blinking driven by the I/O module. So this is basically proving that we can, this is what I was going to, the LED ended up working well. I didn't know if we'd be able to see it. This is what I was wanting to connect the oscilloscope to. So it should stop blinking soon. There we go. So it blinked 20 times. So it would have taken 10 seconds no, it would have taken 20 seconds because it was a 0.5 high, 0.5 low, so a 1 Hertz frequency. So that was, yeah, anyway, that's what I was wanting to put the scope on, but we can see it. So this basically demonstrates that we now have control of these I/O pins. We can digital write them, as we just saw. We can digital read, we can analog write, we can analog read. There is calibration stuff I've got to figure out with the analog side of things, but at least we're talking to the chip now. So we are actually making real serious progress here. Crispian said, how much current goes through the LED? I don't know. Probably like 15-20 milliamps. Oh, let's see. Resistor LED calculator. Let's see. Because I am lazy, I know the principles of it, but I can't be bothered doing it myself. Because what you do is you take the voltage drop. Oh, I was going to say like 1.7. Yeah, it's a red LED, so around 1.8 is the voltage drop. I want to get rid of the... Oh, this is not very good. Okay, that was... I was running it at 5 volts. Number of LEDs, 1. Wiring diagram. No, I want the values. What? What? Oh, yeah, okay. So LED current rating, I was wanting to do it the other way around. I wanted to give it a resistance and have it calculate what the current would be, but let's just see what this does. Okay, so that's saying 160 ohms to give it 20 milliamps. So it was probably getting somewhere around 16 milliamps. Let's see if that changes it. 200 ohms, no. This is a very backwards way of doing things. 270 ohms, oh, bracketing it. Let's see if it was about 14 milliamps. 240 ohms, somewhere like that. What I did was I actually gave it, what I stuck on was a 220 ohm resistor. 13? Yeah, anyway. Oh, maybe it was 11 milliamps? No, anyway, I'm going the wrong way. It was somewhere in that 15 milliamp sort of range. Wagonload says, can you use a 360-degree magnetic encoder to ID the I/O mods? That feels like massive overkill. I think it would be better to do it electrically in some way. John says, a year and many mods and I've reinvented the Arduino. Yeah. In a very, very complicated way. All right, so the point is, okay, let's do test IO mod, and I'm going to test digital write.py, vim test digital write. So let's simplify this down. I'm going to get rid of, I just want to go for like a semi-minimal thing. Get rid of that. Get rid of that. and get rid of all of that. All right, so the point of this is I am simply making this, I want to make this as simple as possible. It's just, this is what it comes down to. In order to drive a pin, high or low or whatever, it is now possible to simply import the IO mod library, initialize it, and then write. Like, that is it. So I'm going to, let's test that. I'm not going to hit enter yet. I'm going to go test digital write, and we are going to come back across to here. You can see that the LED is off, and I'm going to reach across to the keyboard and hit enter, and we should see it turn on. Yay, it just turned on. Okay, so what that has just proved is that, oh yeah, and you can see there's some verbose debugging going on here. I've got it, that's all in the driver library, so that'll all be silenced out later. But if we look at it, like, it's as simple as that. So that is the degree to which all of the hardware has now been abstracted. And I'm really happy with that, actually. That's really satisfying, because it means that you can now write a test runner in Python with only a couple of lines of code and not caring about how all of the underlying stuff works. Because the person who is writing these tests shouldn't need to know how the 805593R works or whatever else. It should just be, I want to write to that pin and then read from this pin and see what happens, and then do a test on the outcome. So that's cool. Mike! Good morning, Mike. Mike says, I assume the modules are not off-the-shelf units, then just add an identifying system when you design the modules. They are not off-the-shelf units. That is correct. They are, in fact, I think I, GitHub, did I update GitHub with the latest version? I think, oh yes, I did. Okay. They are, that is the 805593R version of the module, and that is the pinout. But this is like a generic pinout for any module that might support this format. That's the mechanicals for it. So it's a metric dip format, and there's a metric to imperial adapter. So the 805593R version is just the first implementation, and then I've also laid out some other implementations that I haven't actually built yet. But we can talk, depending on the module, it might be SPI, it might be I2C, and for a while I was also wanting to support serial comms. So the thing is that you might have a module in here, like you might have an MCP23S08 based module in here, which is using SPI, and then it's never going to respond on the I2C bus. So if you poll that slot on I2C, it's going to say there's no module there. You have to talk to it on SPI to discover that the module is there. So that is a whole extra level of complexity here as well. Yeah, so one option would be wagon loads. The simplest would be pogo pins under each mod that just gets a binary code to ID the mod. Yeah. Yeah, this is all adding complexity. Yes, maybe. My feeling is just that it's too much, though. I think that what is there already is adequate, and the ability to interrogate the module, either I2C or SPI, and then see what response you get, I think that is going to be enough for most things. In fact, I think for almost all situations, the modules that are in there are going to be 805593Rs. The reason that I made this modular and supported both interface types is, firstly, if you have a disaster and your device under test sends like a high voltage down one of its I/O pins, like say you are testing a device that has a 24 volt power rail on it, and you are feeding power in from an external 24 volt power supply. Worse than that. Say you are testing a module which is a power over Ethernet device, and you are sending 48 volts into it externally from a PoE source, and there happens to be a solder bridge somewhere on the device under test that hard links 48 volts onto one of the I/O pins, and you have just injected 48 volts into the I/O pin on your tester, and all of a sudden, boom, the test module on that port is dead. It's never coming back. You need to be able to replace that test module and do that reasonably easily and at minimal cost. You don't want to have to replace your tester just because there was a fault on your device under test. So so that is a major reason that I made these I/O blocks all modular and replaceable. The other is just to allow for potential future variations, like say you needed a 20-bit ADC or something, or you needed a high-speed ADC, then you use SPI, or you need a module that does something, I don't know what in particular, then you can design a module for it. It just gives future flexibility to replace or maybe the 805593R is replaced by a new version that has better resolution, like maybe they come out with an updated version of the chip. I don't know. So yeah, it's to provide protection for the tester and easy repairs to the tester and future expansion. But my suspicion is that in almost all cases, the I/O modules are just going to be populated. They're all going to be the same. They're all going to be 805593Rs, and that won't change. So I'm kind of covering myself for future flexibility, but I don't want to do that at the cost of lots of complexity, when that complexity just may not be justified. So I'm kind of hedging my bets there. Pete, thank you for the $1. I am gonna, okay, you have just paid for the next swig of my coffee. Oh, happy birthday, Mr. Fix-It. Yeah, happy birthday. Oh, that is cool. Hence 1952. Yep. Made it to 73. Happy 73rd birthday, Mr. Fix-It. Yes, that's a cool thing to celebrate. Mr. Fix-It said, been hanging out with you guys for around 10 years, maybe longer. Wow. That's awesome. Yeah. As Debray says, happy birthday, Mr. Fix-It. Great day to be born. Yep. Mike says, then forget about being able to identify and just document how it should be set up for each test and load the correct code. Yeah. Yeah, there is a compromise level in here between super automating everything and making it all interlocked and auto-detected and auto-configuring, or you have a list of what modules should be installed and you trust the operator to have the right modules installed, and then you just blindly try. So it's a spectrum. So somewhere in the middle of there, what I think is the right thing to do is to have the test specify what the module should be, have the test runner interrogate the modules and check that they are what it expects based on the test definition as best they can. And that may not be 100% accurate. It may be as simple as, is there a device on this I2C address? And that's it, like that. But just that check alone will probably catch almost all problems. So yeah, I think that is the reasonable compromise. Okay, and now I am going to have my celebratory drink of beverage, thanks to Pete. Okay. Mr. Fixit says, now if I can go another 10, that's the trick. Yeah, you'll do it. You will do it. Go another 10. We will be back here in 10 years celebrating your 83rd birthday. Yeah, you can do that for sure. Now, where are we? That's right. I opened Fusion because I was going to show this. What is the time? 11:21. Okay. And now we are almost getting to the point of what it was that I was wanting to talk about today. And this is something that I've already talked about just a little bit with people on Discord. So there is the, sorry, I'm just opening that. Yeah, I'm going to show why pogo pins on the bottom of the module are not necessarily going to work spectacularly well. So this is the module, like that is what you would expect to see. Because these modules are populated upside down, they have a smooth top on them. This top is actually the bottom of the PCB. The parts are all hidden underneath. So there's the actual I/O chip and various supporting jelly bean parts. And so there are very few places there where you can stick pogo pins. And on other modules, it's worse. How far did I get with this one? Not very far. This was me partway through doing an SPI version, and then I got distracted or gave up. I'll say that I got distracted rather than gave up. It's because I was trying to figure out voltage buffering. So let's get that out of the way. So yeah, the TXB 0104, which was suggested by Stephen as a level shifter for SPI. That's what I was experimenting with, including in the design. And then that's as far as I got, and I just put it aside. So this is a version that would have multiple QFNs on it. And yeah, the bottom of the module would be very much used. So, and then there is another one that I laid out. Did I actually finish this one? I think I did. Yes, I did. Okay. This is a version of the I/O mod based on an MCP 23008. So this is a simple, it's just digital only. There's no analog I/O on the MCP 23008, but this is an alternative version of the I/O mod. And this design is fully done. I could fabricate this. I just haven't sent it off for fabrication. I wanted to see what it would be like to design an MCP based I/O mod. And where are we? That one. This one. Is it complete? And my thinking was, for many situations, an MCP 23008 is all you need, because you only need yeah, just digital I/O for a lot of stuff, and they are cheap. So this would be a lot cheaper than making the AD 5593 based one. So you've got digital I/O there. It's got level shifters on I2C, so that it can support the different voltage on the I/O. So the actual chip actually runs at whatever voltage your I/O needs to be. So we've got the VIO here, and then we've got the voltage of the bus. and there are level shifters to support that. So this is the the MCP 23008 version of the IO mod. Yeah, so there you go. Now, where was I? Oh, Faisal is here. G'day. Mr. Fixit says, for my birthday I hauled 16 4x8 pieces of half-inch sheetrock into the house. I'm getting too old for this Murtar. How do you pronounce it? Murtar. Yeah. You can put ground pads on the edge of one end in binary that pogos can detect, said Wagon Loads. That's true. Yeah, I could if I could possibly find a bit of space and designate it. On the, although I have been tight on space, I've got to admit, I've been struggling to fit things onto these modules. Scott says, you'll know you've chased one too many squirrels down a rabbit hole when you determine the need to design a through-hole chip in the same footprint as the IO mod. Yeah. Oh, VL Andrew is here as well. Welcome, welcome. Oh, Amanda said, I've been printing red camera lens caps for my camera lenses so I don't forget to take them off or lose them or put them back on again. That is a great idea. That is a great idea because camera lens caps are normally black. You put them on and they're invisible. You can't, like if you just glance at a lens with caps on it, it's not super obvious that the caps are on. But if they're red, then they're obvious. That is, yeah, Crispian says, same as in Lethal Weapon. Exactly, that's why I was saying Murtar. It was Murtar and Riggs, wasn't it? With the detectives in Lethal Weapon. Double stacked PCB. Sorry, mods. Okay. I can't remember how long it is since I've watched Lethal Weapon. It must be 20 years since I've watched Lethal Weapon. It's got to be something like that. How is it that I remember that the two main characters are Murtar and Riggs? Yeah, I don't... Murtog, Riggs. Is it Amanda? Murtog, okay. Yeah, it's not Christmas, so I'm not allowed to watch it. Oh, Crispian said, we rewatched them all a few weeks back, still good today. Yeah, but it's not Christmas. No, I was thinking of Die Hard. Die Hard is the Christmas movie. Lethal Weapon is not a Christmas movie. I haven't seen Die Hard for probably a couple of decades either. Anyway, let's not chase that squirrel right now. So, back to the point. Okay, now, yeah, so as we've demonstrated, I need to do some tuning, but we can now create a Python, like a simple Python script that will read and write the I/O pins, and this is the extent of the infrastructure. Like you import the library, you create the object, and boom, we now have access to all of the I/O pins on all of the modules with one command. So that is really cool. Like, yeah, we could do iomod dot analog write on pin 2 and a value of 42, for example. You know, that would be valid. So it is now very, John Whip says nostalgia is not what it used to be. Yeah. Oh, John said Martin Riggs and Roger Murtaugh. Yeah. Scott says, problem with getting older is reminiscing about the past and realizing how long ago it was. Yeah. Yes. Yeah, like the 90s was just a decade ago, wasn't it? So now, next stage, let's get to the actual crux of all of this. Now that we have this infrastructure in place, we can read and write pins. How are we going to use this newfound superpower? How are we going to actually define a test? And this is, okay. Oh, Jordan. Jordan says, hello, joining late because I was repairing my roof. No, you shouldn't be late for that. A silly reason like that. What you should be sitting there watching the stream with rain dripping on your head through the hole in the roof. And you will like it. Okay, so what did I put in README IO mod? I can't even remember. Oh yeah, okay. So there's some documentation in there. Yeah, and there are examples you can see here. IO mod digital write, IO mod high. This is from the thing. And then you can digital read and assign it to a value. You can, yeah, all of that sort of stuff. That's what I was just demonstrating. So now, what do we do to define a test? Now, I've just got to find this thing. So it was a JSON. Oh, let's see if this was it. Yes, this is it. Okay. Here we go. This is an online editor because, all right, I'm gonna take you on a little journey of my thought process and where I was going with this. So what I was thinking was to use something like JSON or YAML to, is this the right one? No, it's not. This is not the right editor. There was another one. I've been experimenting with multiple editors. JSON to YAML converter. Is this it? Yes, this is the one that I was using. Here we go. Okay. So this is like a live converter. I'll just get this into the right place. Bring the editor up to here. This is a really cool online tool if anybody messes around with YAML and JSON and that sort of stuff. So it does live bidirectional conversion. So like if what am I going to do? I'm going to add another thing in here. Let's go integer, and I'll say 3. And you can see that the JSON over here is updating live as I'm editing the YAML on this side. And similarly, if I change this to a value of 4, whoops, what happened then? You can see that the YAML updated. So it now has a value of 4 on the integer there. So we can, and you can see that it's validated that it is the format is correct, and it'll tell you if you screw up your formatting. So this is a pretty cool way of just messing around with JSON or YAML and seeing that you've got the structure correct. Okay, so I'm just looking for, I had some notes here because I'd already done one. Okay, this is an example. I'm going to put a couple of things in here. I'm just going to paste them in on the YAML side. So this was a thought process of how to define a test. And as I was going down this rabbit hole, I realized that trying to define all of the possible things that you would do in a test scenario becomes incredibly complicated. And by the time you've defined everything, you almost have a programming language. So why not just use a programming language? Okay, so let me let me back up a little bit and which is this? Let's just get rid of one of these and just deal with one. Okay, now we have an object here, and the title of the object, so this is the specific test that you're going to execute, is that the 5 volt is the 5 volt power rail. Ignore abort on fail for now. I'll get back to that. And the fail message, I'll get back to that. The actual test. Okay, so we've got a given when then scenario here. I'll talk about this in just a second. I'm doing this kind of out of order, but I'll get back to this. So this whole given when then thing is derived from unit testing. It's similar to a range actor cert, which if you've done unit testing, you should be familiar with. So the what this is saying is that given or a range, the 5 volt rail, a 5 volt power rail is true. So we're going to turn on 5 volt power. Boolean true. Why did I have that in there? I don't know. Yeah, okay, let's just get rid of that. So all we're going to do is say, given that 5 volts is true, when 5 volts is true, delay 100 milliseconds, then analog read A5. I don't think this is structured correctly. I think this would be, let's rearrange this slightly. So we'll get rid of that. Then we will do when, when, given that, when that, yeah, okay, I'm just going to go for like the simplest possible, thing here, and say, given that the 5 volt power rail is turned on, and we are going to have a delay of 100 milliseconds, then, let's say 5.2, then analog read of A5 should be between 4.7 and 5.2. All right, so this is, what I'm getting at here is we are just checking if the 5 volt rail is within spec. Simple as that. And even this test, once I started trying to figure out how do you define that test, a test as simple as that becomes a problem. It's, for example, you have to specify a delay to allow the power rail to settle, because you, so this is kind of a human readable version of what we are wanting to check. So given that we have turned on 5 volts, when we delay for 100 milliseconds, then we should read between this range. That is the test. And then it'll pass or fail, given the outcome of this. So if this is true, we've passed the test. If this is false, we failed the test. And then we need some more flags. For example, the test runner has to know if your 5 volt rail is out of spec, and this is the very first test that you've done, there is no point continuing with any of the tests, any other tests. Therefore, abort on fail is true. So we're saying that if we have failed this test, we will abort, and we will not run any future tests. We'll just return the error and say, I can't continue, you've got to fix the 5 volt rail. I've got no power on the device under test. And the fail message is 5 volt power rail out of spec. Okay, now in that fail message, it would make sense to include the voltage. So we would say Okay, so analog read A5. So analog read is an operation. A5 is block A pin 5. Should be within this range, but then that has to get assigned somewhere. So we could say then actual voltage equals, now all of this is a bad idea. I'm doing this to explore the bad idea because this is what I was trying to do, and I do not think it's the right way to do it. So we say actual voltage is equal to that, and then in the fail message we put the actual voltage there. So then, oh no, we can't do that. Okay, so then we end up with a string with the token in it, and that token needs to be replaced by the value that comes into actual voltage. Now, what you can see, oh, no. Okay, so John says, how do you define the 5 volts true? Isn't that the test? No. Okay. That is not. That is setting a value on a 5 volt rail. So 5 volts in this case represents the power rail. Now, let's just talk through what the parser has to do. So this is the definition of testing the 5 volt rail. So the test runner has to load this configuration, and it has to set a couple of flags. It has to set the abort on fail true flag. That's easy. We can have a flag for that. It has to set a string as the message to output on fail. In fact, there should be a pass message as well. So there should be pass message, 5 volt rail, okay. And then we should do actual voltage. Okay, so it's got a couple of strings ready to use with tokens in them. Then given, so if it's processing the given block, each of these things represents, now there might also be another one there. There could be A2 digital write high, for example. So these are the conditions that it's setting to begin the test. So the parser has to know that 5V refers to the 5 volt power rail for the device under test, like for the power rail going to it. And when it sees that with a value of true, it has to turn it on. It has to know that A2 is a reference to IO module A, pin 2, and that it needs to do a digital write to high. And of course, there are many more possible things that could be in here, depending on what you're testing. There could be definitions of CAN bus messages, there could be all sorts of things. The delay, it has to parse this and know there is a delay function. It then has to know, okay, I'm going to parse this, and analog read on module A5, it has to do a check here that it is within this range. So it has to know the structure of this message to split the message to extract the parameters. So effectively what we're doing here is we are doing an if analog read A5 is greater than 4.7 and is less than 5.2. So that's like a logical structure. So this is like, basically this is pseudocode. And the whole point of what I'm getting at here is you can go down, oh, okay, imagine an even worse scenario. When can write, oh no, let's do another scenario. I'm going to do, joystick input. Let's do it, capital J, joystick input. Abort on fail, false. Oops. And fail message. I'm not even going to change those for now. given, we don't want that, we want given nothing really. Oh, except that we want to say set up CAN bus on SPI device 3. I'm not going to even come up with a syntax for that. When we can send, and we're going to do, like we could have a whole J1939 format CAN message here. No. What we're going to do, we're going to do the opposite. We're going to do got to get my fingers in the right place on the keyboard. Analog write on analog write A5, and we'll give it a value of 354. Doesn't matter what it is. Then we want can read, and it's going to be 0 hex 0 0 0 hex A0 0 hex blah. Okay, this is where things get really complicated as well. I'm going to just give you, this is a fake example that simplifies reality. So say we've got a value of that, and we want 0 0 0 x A0 0 hex 20. That'll do. So you can see that the third byte here in this CAN bus message is different, and this is a range. The whole point of this is that imagine we're testing a device where you have an analog joystick input, and as you move the joystick, different CAN bus messages get sent. What you have to do is fake the input of the joystick using the analog write, and then you have to listen to the CAN bus messages and parse them and see if the value being reported on CAN bus is within a certain range. It will not be a specific value. It'll be a CAN bus message for the joystick position. It'll be reporting a value, but that value might be off slightly. It has to be within an acceptable range. So you have to configure the test runner, tell it to do a CAN read on packet ID A0, and the value can be between hex 10 and hex 20. Like, how the hell does the test runner understand what this means? The parser for the test runner, like for this test configuration, has to be incredibly complex. And it's just not feasible. So this is the thing where as soon as I start trying to implement real-world examples, the idea of defining a test in YAML or JSON or whatever, so you can embed JSON in YAML. YAML is a superset of JSON. It can do everything JSON can plus more. So if you can't define the test in YAML, then in a simple way, it just ends up being such a pain in the butt. So yes, I just saw that things in the chat are going the way I want them to go. The cunning plan. Okay. Yeah, so I think you can see my point, which is that trying to define tests in a configuration file. Oh, and okay, the other thing for this. Now, imagine that you are wanting, you don't just want to test the joystick position at 1. You then need to do this again at, say, a value of, get rid of that. Okay, we now need to do that again at a value of 150, and now we're expecting a value between 0, 3 and 12 or something. And then you might want to test this joystick position at hundreds of locations, not 1 or 2. So now what you need is to be able to define a loop or a data range or a data set. There could be a combination of different pins. There might be multiple modes. The more you look at this, the more you realize that you are creating a programming language. And if you're going to create a programming language, just use one that already exists. Just use Python. Yes. So, David said, surely Pascal would be reasoned enough. Yeah. Pull the old Turbo Pascal floppy disks off the shelf and install that. As Andrew said, start with Python, then as you work out the repeatable blocks, support YAML. I've done similar in the past. Yes, that is what Stephen also suggested in the discussions that we were having on Discord during the week, because I was going down this rabbit hole and let's start over in assembler. Oh, Wagonload says, wouldn't the IO mod need to test its own output so it knows the CAN bus is responding to the correct IO mod output? Oh, right. I see what you mean. So like a closed loop. So measure the voltage that you are applying to the device under test. Yeah, maybe. Yeah, so make the tester a closed loop system. I don't think that's really necessary because it will become apparent pretty quickly if you are sending voltages to the device under test and you are not getting a response back that you expect. The problem is either you're not sending the correct voltages, in which case your tester is broken or something is going on, or there is a fault on the device under test. So yeah, I don't think that's necessary. Define fail equals true. Stephen says, I think John needs to scrap the lot and start over in COBOL. And Wagonload says, would the ADC reading be skewed if the power rail to the mod was wrong? Yes, it would. That would show up definitely. Yeah. Andrew says, pass and fail should be generated based on the title and type of test being performed. Yeah. So, all of this leads me to load the accumulator. Don't talk to me about accumulators. I'm still in therapy from working with Electrolux. So the point is, I don't think, in the short term at least, it is going to be practical to have some form of configuration. Now, next I am going to show you, what I've got that I want to hook this together with. Now, we have a whole stack of software here. What I've just been showing you so far today is starting from the bottom and working up with the drivers for the I/O modules, going up levels of abstraction to the point where we can read and write pins. Okay, so that's building up, and that is cool. We've now got to somewhere that is kind of vaguely useful. The other side is at the top end, defining the tests, and then how do you read the definition of the test and then execute it to call those I/O pins. That is the other piece. It's like building a bridge, and you're building it from both sides of the river, and the two sides of the bridge are moving together until they touch. We're at the point now where we have the two sides of the bridge heading towards each other. So let's see, what do I have here? CD test runner. Oh no, I want to get onto test runner. No, that one's going to be way out of date. Okay, I'm going to get onto a different device. If it's running, is it even running? Let's see. If it's not, I'm going to have to... Oh, it is. Cool. So what I'm just doing right now is logging onto the other Testomatic, which is in the clean room, cleanish room. And I will bring this up on screen. Here we go. So this is tester 2, which is running in the clean room. And, I haven't defined that. Test runner. I keep doing that because I normally have L as an alias on my systems for, what it does is ls minus L. Is LL an abbreviation? No, it's not. Okay, I've got to set this environment up better. That's what it should be a short for. Okay, so now we've got, what I've got here is a thing. This is going to be super embarrassing as well, but look, let's look at test runner. Should I do this? I'm just wondering if I'm going to reveal anything, like if it's going to reveal usernames and passwords or anything. I don't think it will. Okay, this is a very crude chunk of Python. So what it does is it has a path of where everything is. There are some arguments that get called. So this actual script gets called from Node-RED, from the touchscreen interface, which is running Node-RED dashboard. Node-RED invokes this through its backend. And you can see that there is hard-coded stuff in here that really shouldn't be, and all sorts of ugliness. But this is what is currently working. And you can see that here we've got commented out who is actually running the test. So you've got to edit the script. Ugly things like that. Whole lots of stuff commented out. But down here we have the device under test directory. So we've got targets and the name of the device. And then we do some timestamps. We've got a reports directory where the outputs go. We've got a definition of an upload script. There's a, that's a report. Then we've got a manual checks file. We've got a target.ini. This is where interesting stuff will happen in a second. We pull client name, device under test name. All of this stuff comes out of the ini file. So that's the configuration for running the test. Then we've got some options that can be turned on or off. And then we have a print file, which is P. This is what comes out of the receipt printer. And you can see that it substitutes a whole bunch of things in there. So it's saying the hardware version of the device under test, the firmware version, who tested it, timestamp, automatic checks, manual checks. So what we do is we run the firmware upload and we execute the upload script and capture the output, and then we save the output of the upload for a future reference. Lots of commented out stuff there. Manual checks, it loads and it does stuff. If the printer is enabled, it prints a receipt on the receipt printer. If photo is enabled, then it takes a photo using the Raspberry Pi camera. But I'm not using that right now. So that is the test runner. And then if we look in targets, I'm going to look in, let's look at MCM. This is not going to reveal, this is a client board, but it's not going to reveal anything bad, so it's fine. So what this is doing is we've got the device under test, so the test version. So as the test itself needs to be versioned, because you might improve your testing process, you change your tests, you need to know when you see a test result, you need to know what version of the test was executed to produce that test result. So the tests themselves are versioned, and in this case it's just with the date, and then if necessary with another letter or something appended. The hardware version, the firmware version, the device under test name, so that's the human readable name, who the client is, the path to the upload script, and then we've got options. So install firmware is true, enable photo is false and enable printer is true. So this is the current, what you're looking at right now is the current way that I define what needs to be done for that device. And then there is also the manual checks. So these are the things that we test. And you can see that it's just got serial number on MCU. This is something that a human looks at. So these are manual checks that are performed by the operator. And then they tick the box. This gets printed out on the receipt printer. So you have a physical copy of this in front of you, and as you're doing the test with a pen, you tick the box next to each one. So this comes out, what you're seeing here on the screen, comes out as an actual physical receipt. And so we're checking, is the yellow E-valve header fitted? Is the can termination jumper not fitted? So we're explicitly checking something is not there, because there is a place to put on a can termination header, and we specifically do not place it. So this is a check to make sure it has not been placed, because placing it would be a fault. And the VCal header similarly, we do not populate that header. So it's a check that the header is not populated. Yeah, and you, you go through and you check all of these things. In this particular case, we've got a VCal, which is a calibration routine, and there is a space here on the receipt where you write down what the values are that come out of the calibration routine. So the calibration is done through the serial console. It spits out some numbers and you write them in the box here. That should be automated. Yeah, so there are all of these, even down to things like, have we stuck desiccant in the bag with the board? Like these, is there glue on the capacitors? Has it been conformal coded? These are things that can't be checked by an automated device. They have to be checked by the operator. So that is currently what our test definitions look like. And now what we need to do with this bridge we are building is bridge that gap between those test definitions and executing the tests and actually driving pins and reading values and storing them and that sort of thing. Now, I think the solution for this is just to write it in Python. So what I think will probably happen, if I come into targets MCM here, and then let's have a look at what is in here, that we have manual checks, which is that text file I was just showing you. We have the target.ini, which is the other, that's the ini file I was just showing you. We have upload.sh, which is a shell script that performs the actual firmware installation onto the target device. And there is a tests.sh, which currently, as you can see, is empty. And so what I'm thinking of doing is, let's see, move tests. Let's just remove it. RM tests. So what I'm thinking of doing is something like automatic tests.py, something like that. And then in target, we would have we would have automatic tests equals targets MCM automatic tests.py. So what we could do then in the test runner is look for a configuration in the ini file of automatic tests, and if it finds it, it has a path to it. So what the test runner does, or what the test runner now can do, is execute that. Now, one of the reasons that I've been explicit about this, and I'm specifying the path to it instead of just saying, instead of having a convention, what I could do, for example, is I could have the convention that the automated test is always called automatictests.py. But what if you want to write your tests in Bash or in C or in whatever, in Ruby? Like, there are all sorts of reasons why you might want to use this same infrastructure, but your actual tests are being written in some other language, and I don't want to totally lock that in. So by doing this, what I can do is say the automatic tests script, whatever it might be, is at this location. And then the test runner can just call out to that and run it. And that gives total flexibility to do whatever you like in that automatic test script. Andrew says you could start a test definition config file with just the pin mappings to sensible names. Yeah, yes. Okay, now this is opening another can of worms. I'll just see if I can find my notes about this. Pin allocation, readme timesheet, where are we? Pin allocation, is that it? No, that's Raspberry Pi pins somewhere. Actually, it might be on here, where if I go into cd that, oh yes, I think this is it, cat io config. Yes, okay, now, here we go, another whole can of worms. io config. Now, in the so this is two different versions, one in JSON and one in YAML, of defining I/O pins. Okay, where is this? Oh, Johnny is here. Oh, and Don S, welcome. So this is in response to Andrew's comment about start a test definition config file with just the pin mappings. Yes, so it was my attempt at, oops, I'll undo that. This was my attempt at how you would start setting up pin mappings and then reference them in a config file. So we would have an I/O block and give it an ID of A. And this is AD5593R driver. We want to set the I/O voltage to 3.3. These are the pins. We would probably also do, what would we do? We'd say I2C channel, and this would be channel 0, and then this would all have to be parsed so that the test runner would set up this virtual block of pins and you could reference them by name. So this would be, you would then reference IO block A pin 2, for example, and then read from that. But you could give this any ID you want. Like you could say this is my logic pins, and it is on I2C channel 0, so it's going to be the first module, module A. But then you would refer to it as my logic pins 2. And the thing is, you also have things like CAN bus and serial links. So you need to define all of these I/O blocks, and then you can reference them. So this is another rabbit hole that I started going down. And once again, it just felt like too much. It feels like too much boilerplate and too much overhead for what you can do directly within Python. So with this, what we would have to do is have part of in the test runner, it would need to parse this configuration. So you'd have to write this configuration for your test setup. Then the test runner would have to load this and parse it. And then you could use that information within your tests. Maybe that's necessary. Maybe it's not. But yeah, this is the rabbit hole that I was going down during the week, trying to figure out how to define what all the pins are and what they do, what modes they should be in, and how you reference them. Yeah. Crispian said, so many rabbit holes, so many squirrels. That is correct. Cable tie, welcome. Johnny says, yeah, the government will pay me money from now and the rest of my life and I don't even have to work for it. What? Have you retired, Johnny? I never thought I would say this, but I prefer YAML notation. Yeah. Yeah, it just looks less messy. Like, looking at this versus looking at this. With this, yeah, the notation makes sense from a programming point of view and from a parsing point of view, but it just visually is messy. Whereas you look at this, and it's more like reading language. It's like the difference between Markdown and HTML. This kind of feels almost like Markdown, where you're just writing in text, and it sort of feels more natural. So Andrew says, I reckon you'll find having them in a config file that can be parsed is a lot easier in the long term. Yes. Grant says everything is better than XML. So going back in the chat, where was it? Was Johnny saying, oh, I still work 2 days a week though. I've missed so much of this. I just kicked out the last guest from my retirement party at 3. Johnny, you have just had a retirement party and it is now 3 in the morning. I assume it's 3 in the morning when you say 0300 and then you jumped on this stream. What the hell are you doing with your life? Okay, now that you've retired, what you're doing is whatever you want. I hope it's whatever you want. You all must leave YAML. Yep. So, yeah, 3 in the morning, Johnny, and you're retired. Well, congratulations on retirement, firstly. Okay, that can be your nerd brag for the week, is that you've retired. You only get to do that once. It's your one and only chance to call that your nerd brag. So, nice job. Good one, Johnny. Now, yeah. So, all of this stream has been me painting a picture of where I'm up to with this whole test definition thing. I can now read and write I/O pins. So the foundations are done, almost done. I have the top end that does the test runner with the firmware installation and the manual checks and printing the reports. So the top end is kind of functional. I've just got to jam these together. So I think the thing I'm going to do is what I was showing a moment ago, where I define an arbitrary script in the target definition, and then in that script I'm just going to write Python, and the Python is going to be which one? Test digital write. It's just going to be like this. It's going to use the reference the IO mod library, init it, and then just read and write stuff. And if I have a situation where, for example, I want to send a whole series of values to an analog pin and then check results coming back, it's just Python. That's easy. I can just define like a list of values to send and then responses that I should expect to match. You've got all of the flexibility of Python, and I don't have to write. This is the thing that freaks me out, is the idea that if I try to define all of this in a config file, I have to write a parser. The parser has to be essentially a complete language. I don't want to write a language. I just want to use one that's there. Paul says, use Tappy for Python test output, test anything protocol. Ooh. This might be the thing that makes this whole stream worthwhile. Tappy Python test. I'm just searching for what this is. Tappy tools. This is not something that I have come across before, Paul. So, Tappy is a Python library that provides tools for working with the test anything protocol. Tappy is a simple line-based test protocol used to record test data in a standardized format. Tappy enables Python projects to produce and consume test output. Okay, integrates with unit test-based test cases. Offers a tap test runner as a subclass of unit test. Produces tap streams. Plugins are available. Nice. Okay, tap consumers can read tap files, display test results. Yeah, that could be handy. With mixed programming environments. Okay. This is something that I am going to read about and learn about. Paul, yes, as Stephen W. says, look, a squirrel. Look, a squirrel. Yeah, I do have some reading to do. Oh, and Andrew said tap is excellent. Yeah. Okay. Donna says, is that based on software testing? Yes, it is. So this is unit testing for software. And, but the thing is that, okay, this is actually something that I was wanting to talk about today. The concept of applying software unit testing processes to testing hardware. The way I'm thinking about this is very much that I want to treat the device under test as if it is a chunk of software, which might sound stupid, but if, for example, say you have a piece of software that you are testing and there is a function, or say there's a method. So you create an object and there is a method that you send it some input and you expect some output. That is where unit testing comes in. You create the object in your test environment, you inject data into it, you receive a response, and you see if it makes sense. That is exactly what we are doing when we're testing hardware. It's just that the data we are sending into it is electrical signals. And what comes back could be electrical signals, but this is all being intermediated by the test chassis itself. So we are doing a digital write on a pin, we are doing a digital read. We are in the software environment. We're in the realm of software. And so the concepts of unit testing, like software unit testing, very much apply. You can think of your physical device under test as being a chunk of code. It has certain behaviors. When you send it certain inputs, you get certain outputs. And so my goal here is to avoid reinventing the wheel. I want to take existing methodologies like arrange, act, assert, and, you know, given, when, then, the sorts of things that are, or the sorts of methodologies and design patterns that are used for software unit testing, and just apply it to hardware unit testing, or to hardware functional testing. So yeah, anyway, that was a little, not rant, just an explanation of the way I'm thinking about solving this problem, is treating the hardware as if it's software. It's just that it has been ambiguated. No, it has been abstracted from us. The hardware aspect has been abstracted from us by the test framework. From the test's point of view, it's like it's testing software. You are sending it data, you are getting other data back. the fact that that data goes out, passes through a chunk of hardware which does stuff, and then gets results back, shouldn't matter from the point of view of defining the tests and then checking the results and pass fail and all of that. Okay, that was a long-winded way of saying it. I need to come up with the elevator pitch version of that explanation. Yeah. Yeah. So Don said, makes sense if you can loop back via hardware, then it is a thorough test. Yep. Yes. So Paul, thank you very much for pointing me to this this thing. Tappy is Python's bridge to tap. Yeah. I am definitely going to have some reading to do and get myself up to date. It's a while since I've done any unit testing stuff. So I have done testing, like I have done software testing in the past, but it was years ago. And so my knowledge of the tools and things that are used for it is very seriously out of date. I need to get myself back up to speed. Oh, for the curious, tappy sounds like happy. Yeah. In fact, my mum's dog is named Tappy, but T-A-P-I, and she came up with that name because she thought it sounded happy. That's the so Tappy the dog. So yeah. Johnny says, I use unit testing for most of the code I write now because the testers suck. Oh, I don't quite get what you mean by that, Johnny. The testers? Are you talking about human testers, or what sort of testers are they that suck? Oh, Paul says, what was the Python test runner program called? Are you talking about the one that I'm using? It's just a... I've called it test runner. No, wrong shell. Where is the other? There. Is it this one? No, not there. Let's get rid of that. Is it there? Yeah. So this is on tester 2, which is the old one. I'm going to get out of that and to targets to, actually I'll just do CD. Oh, okay. I'm not in Z shell. I'm in Bourne shell or something, so certain shortcuts don't work. How about that? Yes, okay, that worked. So, stop that. Yeah, it's just called testrunner.py. This is my own crappy thing. It's not taken from anything sensible. It is just, this is just my hacked together script that does the necessary stuff to read the arguments that are passed to it on the command line, because this is actually invoked as a command line script from Node-RED. It doesn't exec call out to execute this. So the Node-RED backend execs this script and it passes arguments to it, which are like hyphen separated arguments. And it gets split. Yeah, I know, very crude. It gets split and then it just starts doing stuff, like it finds the target directory and it finds the reports directory. So actually, as an example of what comes out of this, let's have a look at reports MCM. I'm going to show you one of these. 571, yeah. Okay, so we've got 571 test reports for MCMs. Let's just pick one. 3861, that'll do. Quit. 3861. Oh, that's had multiple tests done. Where are we? 32 for 3261. Let's do 6 tab. Oops. 6 tab. .txt. All right. So this is the test report for this water cannon controller, and this is the output of the test runner script. So it's created the test report. It says who the client is, who when the test was run. You can see that this was done by me on that date, 26th of March, at that time, in that time zone. Firmware installation, then it's got manual checks coming out here, and if we keep going down, you can see it reports the test version that was executed. This is what I was talking about earlier, so we know it was run against that version of the test, and this is a URL to get to the test report. Now, you will not be able to get to that. That actually works. That is valid. Let's get to here. I'm just going to open something off stream first because I want to see it before you see it. And device, oh, it's not, doesn't seem to be running. 3861. Looks like the portal is not running at the moment. Possibly? No, okay. So there's some, I've got to figure that out. Oh, maybe it is. No, that's right. This is just an authentication issue. Okay, I'm going to, yeah, I'm messing around off screen. I know you can't see what I'm doing right now. Oh, that was not found. Why? Why was that not found? Has it not been synced? Why does that not exist? Yeah, I'm just talking to myself because you can't see what I'm doing. That, devices. How is that not in the database? Device search. I'm going to search for 3861. 3861. Yeah. So why is the URL broken? I don't know. Okay. Anyway, that's something for me to investigate later. So this is a test result. Once again, this is not revealing anything that that should not be revealed necessarily. This is not going to give you any critical inside information. But what you can see here, for example, is this is test device 3861. You won't be able to get to this because you're not authenticated. But there's this portal where all of this data ends up, which is a record of this particular device, the SKU, the serial number, the hardware version, when the device was, when the record was created. Oh, you can see here when it was invoiced, the purchase order, it was shipped by Uber. There's a shipping record against it. There's a firmware update record against it of version 8.04 was installed at this time. And if we look on here, the firmware was installed at this time. So then there is also, oops, if we come up to here, upload.txt, writing. So this is kind of screwed up, but this is the output of calling ESP tool to upload the thing, and there is some formatting craziness going on there, obviously, because ESP tool shows its progress report 93%, hash of data verified, leaving hard, resetting via RTS pin. So what I do at the moment is I store the test, and I store the output of the firmware upload into these text files, and they are logged against so it's a report in the MCMs directory because that is the SKU of that particular board. That is the serial number of the board. That is the SKU of the board. That is the timestamp of when this test was performed. Yeah, all of this is stored. So yeah, anyway, why was I showing you this? That's right, that was just the outcome of running test runner. So test runner is executed with, that's right, I was answering Paul's question of what is the test runner. The test runner is just my little dodgy script that does all of this. So now what I could do is in here, where are we, test version, because I added the argument, and it'll be an optional argument at the moment, of config.getDut, where is the install script path, where is the upload.txt, upload output file, not there, upload.sh. Upload command is that. Okay, so we've got if install firmware, get the path to the upload script. In the same way, I could come back up here and somewhere where I'm setting stuff. Where am I setting stuff? Let's see. There. Let's do it down here. Okay. I'm gonna go that. No, not that. I'm gonna do that. Okay. And then escape, get rid of that line. I'm gonna get rid of that. And then I'm gonna do, I don't know, test command. I'm not gonna actually save any of this. This is just like me thinking this process through. Path prefix plus targets, DUT target, upload.sh, that is going to be, it is going to be, actually it's not even going to be that, because we are going to do first a test script. Let's do this. Test script equals config.getDut test script, and what I should do is have that default to, it needs to check later if that actually exists. Now what did I do in targets? I can't remember the syntax I used. Targets MCM, target.ini, I've got, automatic tests is that. So it was called automatic tests. So this would be, I'll call it test script is, test is, here, automatic tests. So now test script will be loaded from the config file looking for the setting for automatic tests. So then the test script command would be, now I don't necessarily actually want to do this because I want to be able to deal with the outputs of the test script, not just fork it as a child process. So, but the naive way of doing this, or the simple way of doing it, would be path prefix targets DUT target, and then that would be test script. Test script. So this would be the really basic way of doing it, is just setting where the test script is and then outputting the error to standard out. So standard error redirected to standard out, or is it the other way around? I can't remember. And then you could call that from within the program further down, like from within the test runner, and it would execute whatever was in that script. So you could just put arbitrary Python in there to do stuff. What this does not do is bubble up the result of that test. So the what we actually need to do is capture the output of that and store it against the test record, and also have like a pass-fail high-level binary output. So I'm not actually going to do that right now. I'm going to leave that in but comment it out, and then sometime later I am going to do that. So here we've got automatic checks. We've got installing the firmware, which it does, and then we have manual checks. What we need to do here is the actual execution of the automated checks will be right in this region of the test runner, somewhere in this area here. But that is for a future day. Okay, I'm gonna go because I'm tired. I feel like I am talked out. I am way over time now. Oh, there are some good dad joke nerd puns going on here. Depends on how current he is. More current with less resistance. Same potential, but what if it's limited by inductance? He might be reluctant. You guys need to go home. Oh, capacity for improvement. Domestic supply. Stephen says at some point John is going to realize he is hungry. That realization has indeed occurred. Yeah. Oh, okay. Oh, hang on. There was a thing here. Where was it? AI is quite good at writing tests, by the way, says Johnny. Yes, 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 yes. I definitely want to, yeah. LLMs are very good at doing things like parsing config file, like reading things and generating things. That is their whole reason for existence. So applying them to this can be very good. Yeah, run Jono pizza script, says Crispian. Yeah, okay. I think I have ranted enough this week. So, to wrap up, to summarize, what is it? Now, what's the line from The Princess Bride? It is, Inigo Montoya says something like, so, to, okay, I've got to find this because the quote is funny. Inigo Montoya, to summarize, where is it? To summarize, no, there is no time. Inigo Montoya, there is no time to summarize. Yes. I am, different quote by different character. It was a misremembered thing. Yes. What was the thing? Mostly dead. What is the famous line? No, somebody help me, please. Stephen says, you keep saying that word, but I don't think you understand what it means. No, the thing is, you keep saying that word, but I don't think it means what you think it means. That is the inconceivable. Yeah, that's the inconceivable quote. No, I am... okay, Princess Bride. Maybe I'm thinking of something said by a different character. Princess Bride. Princess Bride. There is no time. Summarize. I want to find this quote. Full. There is not enough time. Not enough time. Paraphrase. Yeah, time frame to rescue Buttercup. Here we go. Okay. It is Buttercup is marrying Humperdinck in a little less than half an hour, so all we have to do is get in, break up the wedding, steal the princess, make our escape after I kill Count Rugen. That doesn't leave much time for dilly-dallying. The original quote is more accurately, there is too much. As he begins to explain which real, quickly summarizes. Anyway, life is too short to spend time summarizing. Debray says, no, that's the quote. Ah, yes, there it is. Paul has got it. I think Paul has got it. It is, no, Mitchell. It hasn't been working for the last 4 weeks. So there's no TTS at the moment. So Paul said, let me explain. Princess Bride, let me explain. No, there is too much. Okay, I've got to find the clip. Let me sum up. Okay, hopefully.
Are we enemies? Why am I on this wall? Where's Buttercup? Let me explain. No, there is too much.
Here we go. This is what I was trying to remember. Hopefully I will not get copyright strike for this.
Are we enemies? Why am I on this wall? Where's Buttercup? Let me explain. No, there is too much. Let me sum up. Buttercup is marrying Humperdinck in little less than half an hour. So all we have to do is get in, break up the wedding, steal the princess, make our escape. After I kill Count Rugen. There doesn't leave much time for dilly-dallying.
You just wiggle your finger. That's wonderful.
I've always been a quick eater.
Anyway, that was a very, very bad capture of that clip. Yeah. So what was it? Yeah. So what I was trying to get at was Inigo Montoya saying, "Let me explain. No, there is not enough time. Let me sum up." Yeah, that's it. Yeah. Mitchell said, oh yeah, so there's that classic comment. So Cable Tie said, I have only made this letter longer because I have not had the time to make it shorter. So that quote was accredited to Blaise Pascal. So I've heard that quote attributed to different people as well. The whole thing about, I apologize for the length of this letter. I have not had time to make it shorter. Yeah, that came from someone. Yeah, it could have been Blaise Pascal. Yeah. Oh yeah, so Mitchell said, yeah, it's been a hell of a month. Lost the text-to-speech database when the PC balked, so I thought, let me rebuild with Postgres before I push to prod. Well, then chaos came and never got to finalize. Yeah, there is a whole lot of stuff that you've been dealing with, Mitchell. So, Paul Schultz's quote, I was going to include some cash, but I had already sealed the envelope. Yeah. Our Cable Tie says, often credited to Mark Twain, but it wasn't him. Yeah, that's right. Yes, I have heard it credited to Mark Twain. I would have made this letter shorter, but I did not have the time. So that is a reference to the time required to edit down to make something concise. It takes longer to write something concise and short than it does to just blather on, which is why my streams are so long. I just blather on. Yeah. Yeah, I was going to include some cash, but I'd already sealed the envelope. Says the letter inside the envelope. Oh, that's brilliant, Paul. Where did that one come from? I haven't heard that quote before, but it is funny. Simon said, John needs an editor. Yeah. This whole stream could have been about 12 minutes long. Instead, it is 2 hours and 44 minutes and counting. Okay, I am going to go. I'm gonna bail. But today has been basically it has not been an explanation, it has been a summary of where my thinking is up to with the test runner script and how to link the test runner to the underlying hardware, which now seems to be kind of working. Oh, Mitchell is saying say test. Okay, I don't actually have it open. I will open the TTS. Let's see if I can get into it now. It just came up with a gateway error when I tried to open it earlier. So now, ooh, it just came up with a, okay, my login is failing. So I can't log into it at the moment. There's probably some authentication stuff that has changed. So the username and password that I used to use on the TTS portal, yeah, is no longer working. So yeah. Don't worry, still broken. Cool. Well, Mitchell, thank you very much for all the work you're putting into this. I know it's a big thing doing that TTS stuff. Oh, you've had to create a new user for you, right? Oh, BuildBot, says Paul. Yeah, BuildBot was the Python test running software I was thinking of. Yep. When I was doing unit testing, so my experience with unit testing in the past has been, that's very loud. That's Andy sending me SMSs. TTS as a service, yeah. My experience with software unit testing was in a PHP environment. So we were using PHP unit and testing. So at IVT we had, I lost track of it in the end, but at some point we had somewhere in the region of 1 million lines of code, like 1 million slock of PHP, and that was not counting the tests, like the test code. Then I think we got to like 1 million lines of code without tests, and then we started implementing unit tests, and we were using PHP unit for that. So I don't actually have any experience at all of unit testing Python, and I've got like all of about 7 minutes of Python experience. I am just trying to figure it out as I go. So now I need to get myself up to speed on unit testing in the Python environment. And BuildBot seems like the thing to check out. Okay, so but I'm going to go because, as someone pointed out earlier, my stomach has alerted me to the fact that it is hungry. So, thank you very much once again for coming along to another episode of John Shakes His Fists at Clouds and Rants at the Sky. Yeah! And probably during this week, I'm going to be continuing with this test runner thing and experimenting with a prototype test script to exercise the Testomatic chassis and do stuff like send outputs and then read stuff back. The only way I'm going to figure this out is to implement it for real. So we will get there. And, oh, Crispian says, off to the wonderful world of chemist. Yeah, I hope you're feeling better soon, Crispian. And, yeah, you get past it. So, say, test again. I assume that what you are doing right now is you are running the thing at your end and you are getting these outputs because I'm not running it at my end. So, yeah. Have a glorious week. Think about nerd brags for next week. Next week, you got to tell me what is it that you have done this week that you are proud of, or that you are happy about, or that just something good. Yes. And then you can brag about it on the next stream. Bring it up. So like it's kind of working? Yeah. It's working at your end but not at mine. That's almost there. And I will see you all next week. So in the meantime, do something cool, save it as a nerd brag, and I will talk to you soon. Okay, see ya.